Welcome back to Quay Does Leetcode. Today I'm going to be doing problem number 23, merge K sorted lists. So in this problem, you're given an array of K linked lists, and each linked list is sorted in ascending order, and you need to merge all of the linked lists into one sorted linked list and return the head. So this is similar to another problem which I've done on here, merge two linked lists, two sorted linked lists. And for that problem, you have two pointers and you start at one pointer at the top of the first list and one pointer at the top of the second list, and you compare, see which element is smaller, and then you make that your next pointer for your linked list, and you sort it that way. But this problem is different because you have any number K linked lists and you need to sort them. You need to merge them. So how can you do this efficiently? Well, the most straightforward way, say we have 5 linked lists of size 1. So each of these nodes represent a linked list of size 1, and we want to merge these into one linked list. So the most straightforward way to do it would be to start with the first 2 lists and merge them, and so you get 1, 2, and then you have that list and then you merge it with the next list, and that gives you 1, 2, 3, and then you merge it with the next list, and that gives you 1, 2, 3, 4, and then finally you merge it with the final list. You merge this list with the final list 5, and that gives you 1, 2, 3, 4, 5. And you've merged the lists. But how long did that take you? Well, it takes O of n time to merge 2 lists, and you had to do that K times. So it takes O of n times K times to merge the lists like that. But is there a more efficient way to do this? Yes, there is. What if, instead of merging the lists one at a time, you merged 2 pairs of lists? So if you merged these 2 lists, and then you merged these 2 lists, and then this is an empty, there's no list over here, and you merged none with this list, then you would have 1, 2, 3, 4, 5, 6. 5 none, which is just you can just you can just say that's 5. And if you're familiar with merge sort, this is the way that merge sort works. And so then when you're at this stage, you merge these two lists, and then you again merge this. There's an odd number, so there's one that doesn't merge, so you can just merge that with none, and then you get 1, 2, 3, 4, and then your other list is 5 with none, and then you can just merge these two lists together and you get 1, 2, 3, 4, 5. And that took way fewer steps. Actually, the number of lists that you need to merge gets cut in half. Lists gets cut in half each time you merge. So when you cut something in half and in half again, when you cut something in half and in half again and in half again, that is logarithmic time. So this, you have to, merging the lists takes O of n time, and then how many times do you have to do that? Well, it's getting cut in half and in half again, so that's log k. So it's O of n log k time, which is far more efficient than O of n times k. So that is the most efficient algorithm to merge k lists, and it actually takes O of 1 space because you will have to take extra space because you're going to make more temporary list variables. We'll show that when I show you the code, but at least it takes O of n times log k time. So let's see how to code this up. All right, so the first thing we'll do is take care of a few edge cases. So there are edge cases if the list is none. So if not list, or this an empty list, len of list is equal to 0, then we just want to return none. There's nothing to merge. Otherwise, if there's at least one thing in the list, then what we're going to want to do is we're going to want to, while our length of list is greater than 1, so we're going to stop when there's only one list, because if there's only one list, then that means they're all merged into one list. So while the length of list is greater than 1, we're going to pair up each list with its adjacent list and merge those two lists. And so we're going to merge the adjacent lists together and make that our new list. So we're going to have a temporary variable called merged list, and we're going to make that start out as a empty array, and we're going to loop over our list. So for I in range, we're going to start at 0. We're going to end at the length of list, and we're going to increment by 2 each time because we want to merge the two lists together. So we're going to say list 1 is going to be equal to list at I, and list 2 is going to be equal to lists at I plus 1. So I is 0 at first, and so we're going to merge list 0 and list 1 together. But what if there is only one list? Or what if there's an odd number of lists? So if there's an odd number of lists, then I plus 1 is going to be out of bounds. So if I plus 1 is in bounds, we're going to use I plus 1. But otherwise, we're going to default to none. So if I plus 1 is less than the length of lists, then it's in bounds, so we're going to use it. Otherwise, we're going to default to none. And now, it's okay if we have none as our list 2, because if we merge, we know we can merge a list with an empty list. It's just the list, the original list. So that's fine. So list 1 and list 2, we have those. And so first we're going to merge list 0 and list 1, and then it's going to merge, and we're going to, so we're going to need to merge those lists. So, and append that to the merged list. So merge lists dot append, and we're going to call a helper function that we haven't made yet called merge to lists. This function is just going to merge two lists together, which we know we can do. We're going to give it list 1 and list 2. And so it'll merge list 1, and so it'll merge list 0 and list 1. And then if there are, say if there are 4 lists, it'll merge list 2 and list 3 together. And we'll append that to our merge list. And then we need to update our lists once we finish appending all of our merged lists. We need to update lists to be our merged list, because that's the condition that this is looking for. And then once we break out of this condition, there's only one list left. So if there's only one list left, then we just want to return our list at 0, which is the only list that's in there. So now that we have written that, we can write our function, our helper function, that merges two lists. And that problem is a problem that we have already done in a previous video, but I'll just repeat it here. So this is going to be merge two lists given a list, given it's a instance function, and it's given a list 1 and a list 2. And so this this helper function will merge our two lists. And so the first thing we need to do is we need to make a dummy variable for the new list. So we're going to have a dummy node. A dummy node is going to be node list node, and we can give it any value. So let's just give it the value of 0. And then we're going to say our merged list, we're going to start at, our merged list is going to start at dummy. And this is the pointer that we're going to use to iterate through the the output. So while we have L1 or L2, if either one of those is not empty, we can still keep merging. And so while one of those is not empty, we can merge. So let's get the values that we're going to compare with each other. So val1 is going to be equal to L1.val if L1 is the one that's not empty. Else, we're going to give it a default value of infinity, because we're going to be picking the smallest value. So if it doesn't exist, then it's going to be the max value it possibly can be, so that you never pick it. So val2 is going to be L2.val if L2. Otherwise, we're going to give that the positive infinity. So now we're going to check if val1 is less than or equal to val2, then val1 is the value that we're going to, then L1 is going to be our merged dot next. The next thing in our merged list is going to be L1. And then we're going to move L1 forward to say L1 equals L1 dot next. Otherwise, L2 is the smaller one, so our merge dot next is going to equal L2, and we're going to move L2 forward. And finally, we're going to move our merged pointer to merged dot next, so that we can add the next thing on when we get to the next iteration. And okay, so now one of our both of our L1 and L2 are none. So we've iterated through them all. So all we need to do now is return our dummy dot next, because remember, dummy is what's in dummy is a garbage variable, garbage value that we don't need. So our actual list starts at dummy dot next. And so that's the code for merging two linked lists. You can do it a different way if you don't want to use this positive infinity default. You can say while L1 and L2, and then at the end you'll just have to see which one was the one that you didn't finish, and you would have to tack that on to merge.next. But this way you don't have to worry about too many edge cases. So yep, this is the code for merging two linked lists, and combined with the code for merging K linked lists. So let's run it. And we're getting the correct output, so let's submit. And it was accepted. So that is the approach for merging K sorted linked lists. You can do it in O of n times log K time. And as far as the space that you use, you have to make K link. You make these temporary lists. So that would be K space, O of K space. And thanks for watching, and I'll see you in the next video.